out together. Maybe you can tell me. But first of all, I wanted to ask how many of you know actually F5? Okay. Who uses F5? Nobody? Oh, just one guy. So this is going to be a very productive workshop. And my first question is, why F5? What the hell is wrong with them? Who names the company F5, right? When I applied 2.5 years ago, I had really no clue. I was straight out from the university. What is going on with this company? And it took me actually 1 month to realize, why do they name F5 F5? Any suggestions? Do you maybe know? That's something that I thought to myself as well. Like I'm using keyboard every single day. F5 is on a keyboard. That's the first thing I'm going to press. But it's actually not that. I give you a little hint. Twister.
There's 5 people called.
Not really. Not really. But it's a good sign. Twister.
Okay.
The film. Do you know the Twister film? It's like from 1995 to something like that. And it's about tornadoes. So what is actually F5? On a Fujita scale is the biggest tornado. Yeah, it's with the highest wind speed. And those people come into Jeep, they have this tracker at the back of the Jeep, which deploys those small balls. Yeah, and it rotates, senses on the Fujita scale how big is the tornado. So they actually took this concept. It was back then 3 students that really loved to play Quake. And they took this concept of those balls. That's why if you go to the data center and you see F5, it's the only box that is lightning red, because it's a red ball with a F5 logo on it. It's nothing wrong. If it's red, it means it's working. Yeah, into the show. So we started as F5. Well, I call we, but they started F5 in 1996, and they started with Big IP. Why Big IP? Because as I said, those were little gamers. They loved to play Quake, and there was a problem of synchronization on the server side. So they required some big IP to collect all the data and distribute, so hence load balance the traffic and packets among the servers. And there the story begins. What happens next? Well, if you have the SSL coming into your device, you can do something with it, right? So naturally there was another step to secure the requests. And that's why we going on. There's this little problem that we call ball of fire. And in 2017, everybody thought like, oh, we are going to go clouds. Clouds are super easy, fancy. Everybody is going to the clouds. It was a trend. But what actually happened? In the meantime, some of the applications stayed on premises. Some of the applications actually moved to cloud because it was better. And we landed on multiple hyperscalers like AWS, Azure, Google Cloud, you can name it. Some of the applications could reside on the colocation, some on the edges. Multiple vectors, and I don't know how about you, but whenever I finished my degree, I left with only one information. And that the architecture and the system is as secure as its weakest link. And if you see it here, it's very messy on purpose. It might not be as messy, but it's really getting messy, especially in an API world, where everything is communicated through an API because it's easy, it's fun to apply. And we call it ball of fire. And you actually need a method to secure it all, measure the links, have the visibility into every single of the link. And here comes F5. We have 3 family of products. Big IP that I mentioned is the legacy, this architecture, monolithic code those boxes that we provide, like as R series. But we also have Nginx. And many people think, what? Nginx? The web server? One third of the internet is residing on the Nginx currently. So how does F5 owns it if it's open source? Well, in 2019 we bought out the Nginx and we made the enterprise version of it. So you don't have to be alone with your deployment if something goes wrong. We provide the services and the support. And third big pillar that you can actually see, it conveys every single of those, is F5XC that I'm going to talk about today. I'm going to skip Big IP, skip Nginx. I want you to realize we are SaaS. F5 is going into platformization. Let it resonate somehow. So everything that Nginx and Big IP can do can be achieved through distributed cloud. So you can secure every single of your apps, connect for every user, run them anywhere, and have the one single console to see the analytics and dashboards and reports, etc. Are you following me?
Yes.
Nice. So, what is actually XC? Here comes the question. And if I had to start about XC, I would actually have to say, or maybe show you the map. What is XC?
Distributed cloud.
Yes, XC. I call it XC because it's shorter than distributed cloud, which might break my tongue at some point. So the distributed cloud, as the name says, is a distributed cloud along the whole globe that we have. We are currently expanding, adding additional points of presence around the world. But what is the really selling point? It's not like all the vendors don't have such a cloud. All the vendors do have the clouds and probably have even more points of presence. So why distributed cloud? First of all, we are tier 1 provider for this infrastructure. This is an infrastructure that is parallel to the internet. So once a client comes into the network, stays within our cable system, doesn't go out. And second of all, those that you could see here, we call them regional edges. But we also provide to the customers the availability, the possibility to create your own private point of presence, which is called customer edge. So we give you the image, you set up it wherever you want. It could be in a hyperscaler, cloud, colocation, on premises, and you have your own private point of presence in any single location. So it extends this whole infrastructure by your own private pod. And this is huge. You can do a lot on the customer's edge. And you can always hide some applications behind it as well. So you have regional edges, you have customer edges. What we always, well, it brings the most money. But what we always recommend is hybrid model, when you use the best of the both worlds, right? And this is like a summary of everything that I've said. So we have a single SaaS console, centralized control plane, for every single of your teams, because it can integrate multiple teams to use single tool to secure and make the policies for all your ecosystem. And within our packages, let's say this essential package, you get the API security, some sort of bot defense, WAF engine that is similar on every single of our family of products, and DDoS mitigation. This was the introduction. Now we can get to the technical part. I don't know how many of you are technical people. Okay, so I bet this will be valuable for you. And I still have some presents that I need to give out, and I sometimes forget about that. So, can someone tell me from which movie is F5? Okay. You guys know what it is. Maybe you can tell. I believe you were first. Excellent. But I have one more as well. I will not repeat the question though. I'll need to think about something. Let's move on. Oh yeah, I forgot to mention the dashboards as well, to show you a little bit of the insights. But remember that anytime we can always provide UDF, so you will get your own demo system for up to 3 days if you want to test this out, with the lab guides as well. And if you really want to introduce your production site or test it onto your own environment, we can do the POC. Simple and easy. I wanted to mention also, how does this connect? Because you get multiple customer edges, how do they really connect with the XC from the architectural point? You get the, first of all, site token. This is your distributed cloud, this is your own private environment, your own console. Then you take your data center or whatever part of the architecture you have and apply customer edge to it. So it will connect automatically to the 2 nearest regional edges for the redundancy. Create some tunneling and create one coherent architecture. From this console, you can apply to your website a holistic policy. So you don't actually have to go to the AWS, to the edge, to private cloud. In order to utilize the same policies, you use the console to do them all. And also, what if you wanted to skip our backbone whatsoever? We can create an SSL tunnel between your 2 endpoints, so we never process any information that you have on your private customer edges, if you require that. And I mentioned that some other people, other vendors have maybe even more points of presence than us. But we as a network are one of the most peered networks, so we have very good connection to every single location. And it's public data, you can always check it. And here we come to the API security, something that was embedded within the name of this presentation. And sometimes maybe not sometimes, pretty much all the time, when I ask my clients, how do you measure your APIs? How many APIs do you have? What type of APIs do you have? The answer is, we don't know. And my question is, how can you make something secure if you don't know it? Right? I really like those long pauses. So F5 actually comes in handy. And we provide you the API discovery, which can help you with visibility into your API endpoints. So how does the API behave? What is their suspicion score if anything changes or misbehaves? How many of those endpoints do you have? How many shadow APIs do you have? All those concepts. I will describe them all, but first of all, I want to tell you how do we achieve this tree of APIs. There are 3 ways to achieve that. And maybe that's the question to you. Can anyone think of the first way? Can anyone think of the first way? A mystery box. What's in the mystery box? One idea. How would you check?
Ping the destination.
Sniff the network or
Okay, hands up. I need to pick one. Because there are very good answers. Yes?
Interrogating the network?
Yes, so basically, we can show to everyone what's worth winning. We can go and put maybe some bots to traverse through your organization to score and see what endpoints are available. This is the first way. Second way, I will tell you. Second way is if you have a repository, repo, you can directly attach this to the FC, and we will scan your repos for the code, especially for the unused part of API that might reside in your application. And the third one is just to analyze the traffic patterns based on the activity of the clients. So if someone comes, well, we have the full visibility of that, we build the graph. You can always switch from the graph to table. I don't have a screen for that, my mistake. But the clue is the same. Whatever you say in English. You get the list of the APIs, of the shadow APIs, and you utilize the machine learning in order to build a baseline for the API behavior. Why is that? Because nowadays you have a lot of APIs. And sometimes API is embedded within API, or maybe you could hear, or did someone heard about XZ attack a couple of years ago? Anyone?
Yeah.
The attack that almost, let's say, frees the whole world.
OpenSSH?
Yes.
Yeah.
Yes. So how did they perform this attack? It was XC, which was the compression library. Someone just got to this library and implemented, probably a group of hackers, a malicious code embedded within this compression library, and then wanted to create a backdoor for SSH in order to get to any server on the internet. So you can see how a little part of something bigger can create an attack vector. It's very similar to the APIs. If you call an external API, you don't really have a clue at which point does it call maybe another API. Something worth noting. So I said we have machine learning, baseline behavior. So if the API changes its behavior, you get immediately an alert. So this is something worth noting. Another one would be detect and outliers and shadow APIs. Sometimes you have those shadow APIs. What does it mean? Well, maybe developers just implemented some part of the API that's no longer in use, but every single not washed API endpoint can be a backdoor to your applications as well. And you have the Swagger export, right? Whenever, maybe it's on the next slide as well. Yeah, Swagger import. So whenever you develop an application, you can create this file, which will tell you how many of those APIs do you have. You can import them directly into the XC console, and based on that, you would receive a WAF engine policies ready to implement. So it's very, very convenient for you to secure the API endpoints using this. So whenever you have the CI/CD and continuous development of your application, you can always new Swagger files, import it to XC, and adjust your security measure accordingly. Discovery and validation of API. So that's what I said before. Once you discover them and authenticate, you can create easily protection rules, so block, rate limit, some parts of the application, so nobody tries to go in and maybe create a BOFLA or BOLA type of attack, where let's say you are in a restaurant and you have your receipt, but if you look closely to the table next to you, you can see the receipt of the other person. This is some sort of the broken level of the authentication, and we take every measure in F5 to prepare you for those kinds of attacks as well. And I believe this is last but not least for the API stuff, which is risk scoring. So after you have this amount of leaves and API vectors, you get the risk score of how much of each of the API is actually risky, evaluated from 0 to 100. Oh, yeah. And what actually comes with the essential package of the XC is web app scanning. This is something that not every single company does, and I think it's very beneficial. You might actually implement some third vendors in order to achieve that, but we give you this in an essentials package. So what happens? You just implement, apply web app scanning onto your domain, and our bot will go through and search for every single attack opportunity that it sees, creating a live video up to like 12 hours or something that you can watch and see what did it perform. It will list you all the OWASP threats that were detected and help you analyze how vulnerable application you have. Sounds cool, right? Yes. Nice. I'm so happy. I feel like I'm being listened to. I've got the power now. Okay. Let's go to the bot defense. Because nowadays, we say that 88% of the whole internet is bots. And do you really feel like you're threatened? Not until you you want to develop your own application. So, I've created my own game. It was a game inside of the browser that you can actually play. Maybe some people recognize Dungeons and Dragons. Yeah, so I created my own virtual tabletop to play with my friends, just for fun. See how far can I go. And I wanted to test it live with them at some point. And you can't believe it until you really set up the applications and see how many requests per second do you get trying to get like a credential static attack or whatever, only after you implement it. So this is a real risk factor, and XC actually blocks the bots in some more superstitious, I don't know if that's the word, way. So, imagine that you have a delivery guy. Someone ding dong calls your home, and this delivery guy has a package. Who wants to open this package? Nobody? Come on, it's course. You were first. But wait, not yet, okay? There's nothing really going on. Nothing is really happening these days. You don't have a birthday. Nobody died or something. And you receive just this anonymous package. What do? Do you open it or not?
You check it.
Come on, guys, you work in cybersecurity. Do you open it straight away? Give it to me. Give it to me. There's a couple of things that you can do before that, right?
Check.
Take it before.
Yes! Yes! We've got some clues. First of all, you shake it. What's inside? Please shake it for me. Okay, something solid, right?
Yes.
Yeah. Is it heavy or light?
It's a bomb.
Between.
Okay, in between. Okay. What else can you tell me about this package?
It's free.
It's free. Yeah. Is it branded? Yeah?
Yeah.
It's branded. Oh, damn, I signed it. I gave it away, but it's by F5. Can you see the intuition?
It's a small.
Yes, it's a small package. Right. The intuition is you get the package. And your first thought is open it. But before you open it, you can do so many stuff. So many stuff with it. And the same applies to the packets that flow around the internet. Before you actually open and see the packet, you can implement a script that will measure the size of your package, anything that you can think of. We actually do 146 of those things before we even open the package. Why? I'm talking about bots. Why do I talk about package? Because if you take this brick and lay it with another brick, you create a wall. Because once you collect behavioral data of how quickly does someone move the mouse around, is it spamming clicks? Does they click and release immediately? Those are the indications of human behavior, right? And if you have a machine learning powerful enough to comprehend those within seconds or less, even milliseconds, quickly you realize that you get a visualization of who is on the other side, what's inside the packet. Is it a human or is it automated bot? And it's easily visible for the first glance, right? But what is actually a bot? I asked myself a question. And you know what? Cloudflare actually comes with the very nice definition. I love what the pen does. And they say that bot is a program that performs certain tasks in place of a human. Sometimes its function is automated imitation of human behavior. This is a cool quote. Guys, do you understand this? So the reason why we implement the bots is not because we really want to search for the vector attack. Well, it's kind of the bots as well. Those kinds are as well. But most of the bots that go and search the internet are doing something automated. Either they scrap the data or they perform the credential stuffing. So not search another way to get into your application, but stretch it to the maximum. Nice. Are you with me?
Yeah.
Yes. Beautiful. So I have this little example of a sneaker bot. You take New Balance. So every once in a while, some companies come into the collaboration with big celebrities, big names like Michael Jordan or Kanye West. They create this special product. In this case, this is sneaker. And they create this for limited amount of time, limited amount of supply. They announce the date of the drop, when this will be available, and then you gotta fight for it. And can you really fight with bots regarding that? Obviously not. And if you don't have the proper way to address that, well, it's going to come with a huge, not only the technical risks, but also like a visual appearance, right? Is this how you how you call it? Why? And my question is, can you spot something is wrong with this slide? Can you spot what?
Human, the obvious spider.
Yes, all of those are correct. And in macro scale, it doesn't really appear the first glance, but if you go to the micro scale, you can see that actually really small percentage, really small percentage of the whole traffic is human. And in this is actually a real scenario, and this is a real screenshot. Can you guess how many of those were humans? So from 741 million, 740 of those were bots and automated. 99.8% for one sneaker shoe. Crazy. 99.8. And you still have to process all this data through vendors, firewalls, routers, a lot of stuff needs to handle this amount of traffic that you might not be prepared for. And there are lots of types of bots, not only the sneaker bots. You also get gift card rankings. So bots that go in and try brute force gift cards, so to just add some money to your virtual wallet and then buy physical products. You lose the revenue. Or one of those would be credential stuffing. And credential stuffing is pretty weird. Why? Why does it work? Because we are people, we are human. And it's always the case that the weakest link in all the system is the human. Who uses LinkedIn? Who uses LinkedIn more than 5 years? Okay, you have some people. So actually a couple of years ago, there was this huge leak of the credentials from LinkedIn with the emails and passwords. And at that time, LinkedIn just asked you to change the password. But it's probably your favorite password that you've been using your whole life. Come on, guys. Do I really have to memorize another one? Come on. So you still use it. You go and use it on the other website. How stupid of us. But we all do that. I do this as well. It's crazy to say. On some shitty website, I just use my shitty old password from when I was 7 up to 12. Damn, I was so creative at that time. And I use it, right? And this is why it works. So the leakages are happening all the time. Your credentials are all over the internet. Always. And you are probably not using the KeePass manager because we are too lazy. So I wanted to show you how does the attack works. So I created this little demo where I wrote a simple website that you can actually use the email and passwords. Then I created a script with automated bots, which in 5 steps actually use the database of 26 passwords that I had. One of those, as you can tell, Mr. John Smith is this guy who's getting vulnerable. And I actually got a hit. And if I try to go to my website and see if I can log in, there's a perfectly visible 200 OK. So right now I'm good to go. Mr. John Smith, we are ordering a flight. We're going to Poland. No, not to Poland. Well, that's your life now. And on the other side we have f5-Your, with all the 26 transactions being notified, right? And only if I press, instead of reporting, blocking, this attack wouldn't be successful. Good. So how does the typical attack works? From our point of view, as a vendor that actually gathers a lot of data about the attacks, we typically see this pattern where, first of all, we flag and observe the baseline. How many of those incoming traffic is automated. And then, at some point, when we have a fingerprint, we can mitigate and just block it. You can see, if it's an ongoing attack, some of it is happening in red, right? It's being blocked. But some of it is still getting reported. Someone changed the bot in flight on the other side, because once you start attacking, you really don't want to stop it. Damn, I've got 2,000 boots to buy. The money is on the floor. Come on, guys, I need to pick it up. So that's why we come in handy and do the second mitigation, second printing, and we adjust live to the bots. We don't have this one fancy way of looking at the bot that always works. We adapt to each and every attack. So at some point, attacker sees that, oh, there's no opportunity for me to gather some money, so he leaves. And if you search some Reddit forums, I did, you can find some different scripts for bots that actually go around and, let's say, for vendor X, they disobey their bot defense for vendor X. What do they write about XC and shape technology that we have? No wolf. Basically, if you have implemented bot defense, you stop getting those types of attack. Why? Because people know that the shape security is so good that there is really no time to fight with it. You rather go to somewhere else, and this is like a policy for you. That once you get the bot defense, the attack stops. Because it's not wolf attacking. That's a quick anecdote. And what do we actually measure? Well, I said we have over 140 things that we can check for in order to build this brick by brick wall. We can check for the size and resolution of the screen. Do you run headless browser? Right? Do you have some plugins installed? Especially those that help you attack. Do you have installed fonts? Because if you are using Kali Linux, for example, you want this to be as lightweight as possible, and you don't even install some of the fonts. And some of the attacks can actually happen also from the mobile phones. So we check how the emojis are processed. Pretty clever, right? Okay. What happens from the native apps in mobiles? Because maybe you don't know, but there are some human mobile factories in India. Let's say thousands of phones connected next to each other, and they perform some attacks. So we measure the brightness of the device, the temperature around. Can we correlate some different phones that are trying to reach our applications if they are maybe in the same warehouse? And we check the height orientation in gyroscope, because there's really very low amount of use cases where you place your phone like that, it's perfectly still, you don't move an inch, and you perform thousands of actions per second, right? This just doesn't make sense. I'm too lazy for that. And what actually happens for the browser? We inject the JavaScript to the website, so it collects all the data. And some of you that are a little bit more advanced can think, okay, I can install Wireshark, I can intercept the packages and see inside what is actually being collected by my JavaScript. So you can do it, obviously. But so for some vendors, it works. It shows you all the list of the possible features that they look for. We do it differently because we try to be impossible to reverse engineer. Once you have injected JavaScript, it will live only 15 minutes on your computer, and after that we will change the algorithm. So there's really no possibility for you to break it. And we really care about that, because we really want to be the best in this technology. So to recap on what we actually talked about bot defense is we are collecting the telemetry and going from the less to more complex. So are the headers in the right order? Did the client execute JavaScript or try to bypass it? Is client authenticated, or is someone reusing the payload? Those are only a couple of features that you can measure, but we do 146 or more maybe at this point. So for each type of the traffic, you can set different defense mechanism, because not always you want to block someone. Not always you want to block someone, because if someone is trying to reach your application, maybe it's better to set up a void endpoint where bots go instead of being blocked, so they don't really have a clue what's going on. Right? Or for some bots, like scraping Google bots, you want to allow them. Why would you allow some bots to enter your application? Because you want to be positioned positioned higher in Google search. Simple as that. Web app firewall, and I know we are short on time, right? I will go quickly through it because there's a very similar story that we utilize the machine learning in order to protect our bug policies. So error rates, we score every single user that comes to the application and see if they have the malicious intent or not. We score them based on the IPs, and let's say last Thursday you try to intercept the package of some sort. I don't really want you again in my applications, those type of things. And we keep this database of IP reputation amongst our clients, so we notify each other about possible bad IPs. Something also which is happening on the big IP, some of you might know it, we have threat campaigns. There are large organizations, hacker groups that actually perform organized attacks. And we measure them and keep track of them around the globe and try to correlate if they actually try to target your application. And if yes, they will be blocked. You get the whole sort of the security and dashboards to keep the track and eye on everything, right? I really want to do some questions, so I will quickly go around the DDoS mitigation, which for the level 3 and up to 7 is included. And if you, for all the HTTP requests, if you want to traffic the whole infrastructure, so the whole flow, you can use the add-on to the DDoS mitigation. And DDoS is still one of the most popular attacks nowadays because it's very simple to do on every single layer. And different sectors have different split, and you gotta see for yourself which works best for you. So we have up to 18 terabytes of scrubbing capacity. For example, highest DDoS ever noted was around 2.5, 245, if I remember correctly. So this is more than enough, I would say. And you have two options, always on and always available. So always on is when you always route the DDoS through our regional edges. So you are always protected. But if you want to save some money, you can choose always available, where we deploy monitoring of your routers. And if we see the increased amount of the traffic, then we will only push your traffic through the regional edges in order to block the DDoS. And I believe we are finished, so I'll get some questions instead.
Do you have any hardware devices that we need to deploy? For example, if we need this solution, we want to implement this, do I need a hardware device or is it just software?
No. XC is software as a service. We have our regional edges. They are the full computing power. You just connect your applications to. As I said, we have the option to extend points of presence to your local hardware. So then you get the hardware and we provide the image and you can extend it. And only then you get the hardware. But if we are talking about the standalone XC, nothing. You just need this. You get the console, and inside the console you can Thank you very much, guys.